Good morning, students. Now, I am continuing the rational numbers chapter. In that, last class we studied about the associative property of addition, commutative property of addition, commutative property of multiplication, and different rational numbers, positive rational numbers and negative rational numbers. Okay, today I am continuing that rational numbers chapter with some more examples. Okay, so in the last class I showed you that associative property of addition for positive rational numbers, right? Here in this example, I have taken the negative rational numbers. Okay, whether for negative rational numbers also associative property holds good or not. Let's check this one. Okay, then after that we will go for a multiplication property of multiplication. Right now, here in this A is 3 by 7, B is minus 1 by 2 and C is equal to minus 2 by 5. Clear? Now, you know that the associative property of addition, the general form is A plus B plus C. So, grouping in different orders, A plus B plus C. Okay, I have taken only 2. Right? If you want, you can take the third one and check it after my work, right? 8 plus C plus B. So check this one yourself, whether that answer also same or not. Okay, now I am taking the first two, right? Now A is what? 3 by 7 plus bracket B is minus 1 by 2 plus C is minus 2 by 5 is equal to A means 3 by 7 plus B minus 1 by 2 plus C is minus 2 by 5, right? So here is a minus, you can take it a bracket. So this is what the substitution of the values A, B, C in the formula. So just assume that this is a formula, right? Now, here you write on this 3 by 7 as it is plus, take the LCM of 2 and 5, that is 10. 2 is a prime, 5 is also prime. So LCM of prime numbers is their product itself. Okay. So 2 5 is a 10. Now cross multiplication, 5 into minus 1 is minus 5 plus of 2 into 2 is minus 4. So this is 1. Left hand side. Now right hand side again. Look at this, 7 and 2 is prime, so their LCM is 14. Now cross multiply 6 plus of minus 7 plus of minus 2 by 5. Right. Now here 3 by 7 plus minus 4 minus 5 is minus 9 by 10 equals minus 7 plus 6 is minus 1 by 14 plus here is minus 2 by 5. Here both are minus 7. So look at this, the numbers. Now again 10 and 7. 7 is prime, 10 is not prime. So product is 70. So when I take the 70, again cross multiplication, 30 minus 9 sevens are 63. Okay. equals. So you can take it as a plus of minus 63. One. Then here also 14 and 5. Again this is 70. 14 divided 75 times 5 into minus 1 is minus 5 plus 5 divided 70 14 times 14 2s are 28. 30 plus of minus 63 by 70 minus 5 plus minus 28 by 70. So I am writing here plus 30 minus 63. That means you should subtract, you will get minus 33 by 70 is equal to 23 minus 23 minus 5. So again here is minus 33 by 70. So we get the same solution, means same answer. So this shows that associative property of addition holds good for negative rational numbers also. If you take the negative rational numbers and do the addition, associative property of addition, we will get the same answer. Now check this one, a plus c bracket plus b. That means you should add first a and c, then add the sum to the b, whether you will get the same answer or not. So that will work for you, right? So are you clear this? This is the associative property of addition for positive and negative rational numbers. Now let us check the associative property of subtraction, right? Here this is the associative property of subtraction general form. A minus of b minus c. We should check whether it is same or not. A minus b minus c. That means grouping the given rational numbers in different ways and subtract. Then what the difference we are getting, we should subtract that from the remaining one, whether we are going to get the same or not, right? That is what the associative property of subtraction. Okay, now I have taken a simple example. A is 1 by 5, B is 2 by 3 and C is equal to 3 by 5. Now check the first one, A. So A is what? 1 by 5 minus of B is 2 by 3 minus C is 3 by 5. Now that is equal to A means 1 by 5 minus B 2 by 3, grouping these two, minus 3 by 5. Look at the group. First group is B and C. In the right hand side we are grouped A and B. Okay. Now here is 1 by 5 minus of, now again these are the prime numbers. So what is the LCM of 3 and 5 is 15. LCM of 3 and 5 is 15. Cross multiplication 10 minus 9. So 2 5s are 10, 3 3s are 9. Now right hand side 3 5s are 15. Again 5 divides 15, cross multiplication. So 3 1s are 3 minus 5 2s are 10 minus 3 by 5. Clear? Now here is 1 by 5 minus 10 minus 9 is plus 1 by 15 equals 3 minus 10 is minus 7 by 15 minus 3 by 5. Now what is the LCM of, look at this, 5 divides 15. Okay, so 5 is a factor of this greater number. Therefore, greater number is itself the LCM. So when you take the greater number, divide this number by 5. 5 3s are, 3 1s are 3. 3 of 1 minus 15 divides 15 one time, 1 of this plus 1 equals, here also the same 15 divides 15 one times, 1 of minus 7 minus of 5 divides 15 3 times, 3 of 3. Clear? Now I am continuing here this side. Now 3 ones are 3 minus 1 ones are 1, 5, 15 ones are 15. Now this is minus 7 minus 3 is 9 by 15. Look at this, minus 7 ones are 7, minus 7, 3 3 is 9, minus 9. So 3 minus 1 is 2 by 15, and this is minus 16 by 15. So answer is not same. So look at this. Therefore, the subtraction is not associative. Subtraction is not associative. Subtraction is not associative. So associative property on the operation subtraction does not hold good for the rational numbers. You take any examples, whether it is positive or negative, and check it is satisfied or not. Clear? So this is what associative property of subtraction does not hold good for any rational numbers. Clear? Now I am taken negative rational numbers. I am going to check whether the associative property of subtraction holds good or not. Okay, I am doing one negative rational numbers also. Clear? Now here I am doing this in a different way. I have taken this as LHS and this is RHS. So first take LHS. LHS is A minus of B minus C. Okay, now LHS is this. Now let us take A is what? Minus 4 by 7 minus of B means 2 by 5 minus of minus 1 by 3. Look at that, minus of minus 1 by 3. Clear? Now here this you can write this as minus 4 by 7 minus of bracket. Now again 5 and 3. 5 and 3 are prime numbers. So what is their LCM? Their product. So 5 3 is a 15. Now when you are taken the product as a LCM, then cross multiply. 2 3 is a 6 minus of minus 1 into 5 is minus 5. Close the bracket. Okay, now this is minus 4 by 7 minus of 6 minus into minus plus 5 by 15. Okay, now this is minus 4 by 7 minus 6 plus 5 is 11 by 15. Now again 15 and 7. 7 is a prime, 15 is a non-prime. Okay, now LCM is saying the product. 15 sevens are 70, 35, 105. 105. So 105 is the LCM. 7 divides 105 15 times. 15 fours are 60 minus 16 minus 15 divides 105 11 times. 11 sevens are 77. So your LHS is 7. 7 plus 6 is 13 minus 137 by 105. So this is what LHS. That means when you are subtract or grouping the given rational numbers in different ways. So here is the first answer. So let us take this as solution number 1. So solution is what? Minus 137 by 105. Now I am rubbing this. I am taking now RHS. Are you clear this? Now LHS A minus of B minus C. Substitute the values A value, B value, C value and simplify. We get the answer as minus 137 by 105. Clear? Now I am taking RHS. RHS. So what becomes RHS? Here grouping is different. A minus B minus C. Okay. So A is what? Minus 4 by 7 minus of B is 2 by 5 minus C is minus 1 by 3. Now this is again 35. Okay, so cross multiply minus 20 minus 14. Okay, minus of minus 1 by 3. Now this is minus 34 by 35. Here minus 1 by 3. Now, is it 3 divides 35? No, no. So, take the LCM as a product. 3 5 is a 15, 1. 3 3 is a 9 plus 1, 10. 105. Now, 35 divides 105 3 times. 3 into 34. 12, 1, 9, 1, 10. Minus 112. Minus into minus plus 35 ones are 35. Now this is so 102 minus and 35 is a plus. 10 minus 5 plus 2 is 7. 9 minus 3 is 6. So you get minus 67 by 105. So this is solution 2. Answer 2. Now check the first one and second one. Is it same? No. Therefore from 1 and 2 LHS not equal to RHS. So this shows that LHS not equal to RHS means the solution or the answers is different. Answer is different. So answer is different means associative property of subtraction does not holds good for rational numbers. That is the meaning. Clear? So this is the what? A problem with the negative rational numbers, positive and negative rational numbers. I hope you all understand this. Clear? Okay. Now, I am taken an associative property of multiplication. So, in the previous classes, previous sessions, we have checked about the property multiplication, commutative property and commutative property of multiplication. Okay, now this is the associative property of multiplication. In the previous class, we checked the commutative property of multiplication. Now, this is associative property of multiplication. Whether this property holds good for any rational numbers. Okay, now the general form of this is A into B. So, A, B, C or any rational numbers, whether it is positive or negative. Okay. Now, here grouping in a different way. First you can take this one or you can take this one. In any order, you group the rational numbers and multiply, you will get the same answer. That means that we are checking now. Yeah, that is the what? Associative property of multiplication. Now look at this. Let us take A equals 2 by 3, B minus 5 by 6 and C 7 by 15. Now I have taken these three rational numbers. Now A, substitute the value. Now I am substituting both under the same group. Now look at this. 2 by 3 into B means minus 5 by 6. This product is multiplied by 7 by 15. Now equals, here is 2 by 3 into bracket minus 5 by 6 into 7 by 15. Here one thing you should remember, what are there in the bracket, first you should simplify that one only, bracket only. Okay, in multiplication of rational numbers, if there is a chance of cancelling numerator by denominator or numerator by denominator, one rational number's denominator and another rational number's numerator, you can cancel it. If it is possible, you do that. So remember this tables, you should know that. Okay, now look at this. First check that whether the numbers numerator and denominators get cancelled. Okay, now 2 and 6, 2 ones are, 2 threes are. Is it 3 and 5 divides? No. 1 and 3 not, minus 5 and 3 is not divided. So after that simplification, now multiply numerator minus 5 ones are 5 by 3 threes are 9 into 7 by 15 equals, now here is 2 by 3 into, now look at this, cancellation, is there any cancellation? Yes. Here is 5 ones are 5, 5 threes are 15. Now don't cancel these two. No numerator or denominator. Only numerator by denominator. Remember that. Now answer is minus 7 ones are 7 by 3 6 are 18. Okay, this is what you should know that. So first inside the bracket, what is there? There numerator and denominator, if possible, you simplify that. After that, multiply numerator. Remember always while multiplying the rational numbers, you should multiply numerator, denominator. Okay. No cancellation of numerator by numerator or denominator by denominator. Don't do that. Okay. Now next step. In this step, again here numerator denominator will not cancel. Okay. Now I am cancelling this. 5 ones are 5, 5 threes are 15. Don't cancel this 9 by 3 because both are denominators. Now no cancellation of other number. So what you can do is 1 into 7 minus 7 by 3 nines are 27 equals, now here is 2 ones are 2, 2 nines are 18. So minus into plus, minus 7 ones are 7 by 9 threes are 27. So here look at the answer. Left hand side and right hand sides are same. Left hand side and right hand side are same. So this shows that associative property of multiplication holds good. Associative property holds good for multiplication under the rational numbers. Now I am taking this also in a different way. A into C into B. Okay. Now A is what? 2 by 3 into C is 7 by 15 into, what is B? Minus 5 by 6. I am showing that one also, the remaining one. So this is also equal. Now no cancellation of this. 7 2s are 14 by 15 3s are 45 into minus 5 by 6. Now cancellation, 5 1s are 5, 5 9s are 45. Now from 2 table, 2 3s are 6, 2 7s are 14. Now no cancellation, plus into minus is minus, 7 1s are 7, 5 9 3s are 27. So here this also same as this. So answers are same. That means grouping of the given rational numbers in different ways, and if you are multiplied, then we will get the same answer in all the groups. Clear? This is what associative property of multiplication. Understood? Now I am going to continue these properties. Next one is distributive property of multiplication of rational numbers over addition. See, distributive property. Distribute means what? You should distribute. Okay, distribute the one rational numbers to two or more rational numbers. That is called distributive property of multiplication over the addition. So how to write this? So look at this. A into B plus C. A into B plus C is equal to A into B plus A into C. That means here what it says that given three rational numbers, these three rational numbers, first take the two rational numbers, add, and then multiply the sum of these two rational numbers with the remaining one, A. What the answer we are getting is that same as the product of two rational numbers, A with B and A with C. Multiplying these two, take the product, add those two products. Is this sum is same as this? So this is what the verification of distributive property of multiplication of rational numbers over addition. Clear? So these are the general properties. So look at that, how to write the distributive property. Don't confuse with the associative property of rational numbers, addition and multiplication. Here both we are getting into and plus, multiplication as well as addition. Clear? Now let us take an example. A is 2 by 3, B is 5 by 6 and C is 7 by 8. Now let us take this one, left hand side, LHS, left hand side. So what is given? A into bracket B plus C. Now what is A? 2 by 3 into what is B? 5 by 6 plus C is 7 by 8. Now you write down this as it is, 2 by 3 into, now look at this, 6 and 8, they are not prime. Okay, and one number is not dividing the other completely. So in this case, take the LCM like this, 6, 8, 2 table, 2 3s are, 2 4s are. Now 3 is a prime, 4 is non-prime. So take the LCM, 2 3s are 6, 6 4s are 24. So LCM is 24. Now as you are taking the LCM like this, then divide this 24 by 6. 6 divides 24 how many times? 4 times. So 4 times of 5 plus 8 divides 24 3 times. 3 times of 7. So this is what? the way we should do. Now 2 by 3 into, now 4 and 5, 4 5s are 20 plus 3 7s are 21 whole divided by 24. Now this is 2 by 3 into 20 plus 21 is 41 by 24. Now which one is possible to cancel? You can cancel it. 2 ones are 2, 1s are 2, 2s are. Now any other number, don't cancel with these 3 and 12. So answer is 41 by 12 3s are 36. So this is your LHS. Okay, LHS is this 41 by 36. Now coming to the right hand side. RHS. What is this? A into B plus B into, A into C. Now substitute the value of A is 2 by 3 into B is 5 by 6. Group it once plus A is 2 by 3 into C is 7 by 8. Now look at this, 2 1s are 2 3s are. So 5 1s are 5 by 3 3s are 9 plus here is 2 1s are 2 4s are 7 1s are 7 by 3 4s are 12. Now again here is 9 and 12, 3 table, 3 3s are 3 4s are 9 4s are 36. LCM is 36. Okay. Now take 36 LCM. 9 divides 36 4 times. 4 5s are 20 plus 12 divides 36 3 times. 3 7s are 3 times of 7. Now this is 20 plus 21 by 36. So answer is 41 by 36. So RHS, LHS is equal to RHS. So this shows that distributive property of multiplication of rational numbers over addition satisfies the property. So for any rational numbers, this property holds good. Distributive property holds good. Distributive property of multiplication over addition. Okay, distributive property of multiplication over addition. So this is the way to check the property. So all these things will carry 3 marks, 4 marks questions, even for 2 marks also. A simple one, commutative property of addition, commutative property of multiplication. Similarly, for 3 marks or 4 marks, show that or verify the distributive property of multiplication of rational numbers over addition. Only thing is, you should know the tables and how to take the LCM. How to take the LCM and how to add or subtract the numbers. That's why in the first class I showed you how to add the rational numbers, how to subtract the rational numbers. Everything I showed you. Okay, so based on that, so this is what today's session. Okay, so work out this. I'm going to give the problems based on that. So if you have any doubt, you can call me. Right? Clear this? All these things you should work out in the classwork only. What the notebooks given to you, where you have started the lesson. So this is the arithmetic part. What the books you are having, you do the work in that only. What the questions that I am going to give, you solve that problems in that book only. Clear?